Today we shall discuss exercise 12.2 and it deals with distance formula. Okay, here we are going to learn about distance formula between 2 points. In class 10 also you people have learnt about distance formula between 2 points, but that was only in two-dimensional space x1 y1 and x2 y2. Here we are going to deal with distance formula regarding 3 points. Now look here, one point is what? X1 y1 z1 and the other point is x2 y2 z2. Now we want to find the distance between these 2 points. Now what is the distance formula? I will explain to you. I'll just show you, though you people are aware of, still I'll show to you here. Wait, I'll just enlarge the screen. Wait, just wait. Here, look. Oh my God. At the top, you can see the distance formula is given by PQ equals to, you can see, PQ equals to root over x2 minus x1 whole thing square. Wait, I'll just highlight it, this one. PQ equals to root over x2 minus x1 whole thing square plus y2 minus y1 whole thing square, plus there is an extra term now, z2 minus z1 whole thing square. This is the extra term which is we are having now in the new formula. Okay, so we are going to use this formula for all the sums. Now first we shall go through the example. Let us see the example number 3. Find the distance between the points. Find the distance between the points P. Example 3 I am discussing. P 1, minus 3, 4 and Q minus 4, 1, 2. Now the distance formula, what we know? X2 minus x1 whole thing square plus y2 minus y1 whole thing square plus z2 minus z1 whole thing square. So we are using this formula and we calculate the answer to be 3 root 5 units. Now this distance formula, we are also going similar type of example what I have discussed right now, like example 3 we have in the exercise questions also. So ready-made application of distance formula shall be used in the exercise. One more example I want to discuss here regarding example 4. Okay, example 4. Wait, I'll just show example 4. Let me just magnify it a little bit. Yeah, example 4. If you can see the question, example 4, show that the points P, Q and R are collinear. If you see, show that the points P, Q, R are collinear. Now, how to prove that they are collinear using distance formula? What we are going to do is that we are going to calculate all the three distance. We are going to calculate all the three distance. PQ, QR, wait, here. We are going to calculate PQ, QR. See, we are going to calculate PQ, QR and then PR. So three things we are going to calculate. PQ using distance formula, you can see we are getting root 14. QR after using distance formula we are getting 2 root 14 and PR after using distance formula we are getting 3 root 14. Now what you have to do after calculating PQ, QR and PR, we have to check that sum of two distances will be equal to third one. Here you can see these two, if I add root 14 plus 2 root 14, I will be getting 3 root 14. So what I have, last line, see the conclusion, PQ plus QR equals to PR, hence PQR are collinear. So how to find that they are collinear? You have to show sum of two distance is equal to the third distance. Next, the exercise. We move on to the exercise. First question, exercise 12.2, first question, question number 1. Find the distance between the following pairs of points. There are 4 questions under question number 1. So it's ready-made application of distance formula. I'm not going to discuss much in details. The distance formula x2 root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This formula is used in finding out the distance between the 3 points. Okay, I'm not discussing much in details about it. Okay, next, I move on to the next question. Question number 2. Question number 2. Now, in question number 2 also, if you check, what is the question? Show that the points, 3 points are given to you. You have to check that they are collinear. It's just like example 4 that I have explained right now. 3 points. First you name the points P, Q, R. Then you find out the 3 distances PQ, QR and PR. Now if you check the 3 distances that we have obtained here, if you check properly, PR is root 14 if you see. QR is 2 root 14. And what about PR? PR is also 2 root 14. Okay, so it is also 2 root 14. Wait, I'll show you. Wait, let me enlarge it. See, PR is 3 root 14, sorry. So what we have, PQ plus QR, root 14 plus 2 root 14 is equal to 3 root 14. This is equal to the third side. So sum of 2 sides is equal to third side. Hence, we are going to conclude that the 3 points are collinear. Okay, so this was question number 2. Next, question number 3. Verify the following. Verify the following. The first question is, there are 3 points given to you. You have to show that they are the vertices of an isosceles triangle. Now, isosceles triangle, we know 2 sides should be equal. So, we name the points ABC. Then we calculate AB, distance AB, BC and AC. Now, out of these 3, we find that 2 sides AB and BC, if you observe, 2 sides, they are equal. See here. AB is 3 root 2. BC is also 3 root 2. So, 2 sides are equal. Hence, it is an isosceles triangle. Next, question number 3. The second sum, we have to show that the 3 points are the vertices of a right angle triangle. Now, right angle triangle, what is the theorem? Pythagoras theorem we have to check for right angle triangle. So, again, we are going to name the points. See, check number 2. Name the points ABC, calculate the distance AB, BC, AC. Then we show the Pythagoras theorem. AB square plus BC square, we add them up. AB square plus BC square, the calculated value, we add them up and we get the answer 36, which we find that it is equal to AC square. Hence, Pythagoras theorem is proved and we show that it is an right angle triangle. Okay, right angle triangle. So this was question number 3. Now the third sum for question number 3 is you have to show that there are 4 points given to you. ABCD. You have to show that it is a quadrilateral. Now, sorry, it's a parallelogram. You have to prove that it is a parallelogram. Now, parallelogram, how to prove? We know opposite sides are parallel. So once again, we use the distance formula. We find out all the 4 sides. AB, then opposite to AB is which one? DC. Then AD, opposite to AD is which one? BC. Okay, you can see. First we calculate AB, then we calculate DC, opposite side. Next, the third side AD, opposite to AD is the BC, side BC. Now we observe that opposite sides are equal, 6. So AB is equal to DC. At the same time, we observe that AD and BC, they are also equal. So opposite sides equal, hence we shall conclude that it is a parallelogram. So this was question number 3. Next, question number 4. Wait, I'll just try to enlarge question number 4. Question number 4, it is saying that, question number 4, it says that you have to find the equation of set of points. You have to find an equation which are equidistant from the 2 points given. Now, equidistant means what? They are at equal distance. So, introduction you have to take, let P be equidistant from the 2 points A and B. That means AP is equal to PP, midpoint. Okay, then squaring both sides. You can see squaring is done both sides. Yeah, you can see the squaring is done both sides. After squaring done, see, squaring is done both sides. Then why squaring is done? To get rid of the square root. To get rid of the square root. And then we use the distance formula. We simplify. After using distance formula, we simplify and we get the equation 4x minus 8z equals to 0. Okay, you can again take out 4 common. After taking out 4 common, you will be left with x minus 2z equal to 0. So this is the required equation. Next, question number 5. Question number 5, I'll just enlarge it. Here also you are asked to find the equation. But what is the condition given to you? The condition is you have to find out, okay, the equation provided sum of the distances from A and B is equal to 10. Sum of the distances. That means AP plus BP equals to 10. So if there is a point P, then AP plus BP equals to 10. So you have to use distance formula once again. AP. P is a point which we are considering it as XYZ. So use distance formula for AP. Use distance formula for BP. Okay. After using distance formula, you can see this is the step after using distance formula. Take shift one term. Shift one term. Let us shift this term to the right hand side. See, it has been shifted to the right hand side. 10 minus. Okay. Then you go for squaring both sides. Okay. Then you go for squaring both sides. And after squaring both sides, you have to simplify again. Keep on simplifying. You will get an equation. Okay. So what is the last equation you are getting? 9x square. Last equation you are getting 9x square plus 25y square plus 25z square equals to 225. This is the required equation.